Hello. I'm Fernanda Leite from the University of Texas at Austin, and I'm here representing my team, PULSED, Project-Based Learning, Servicing Engineering Workforce Diversity. Our research question is, how does a multidisciplinary, project-based experience impact learning, retention of underrepresented minorities, and early career success of our engineering students? And our motivation for this research is really our belief that in order to solve grand challenges, the grand challenge problems of engineering, we need multidisciplinary and diverse teams. So that's where we're starting from. And our three big ideas are, number one, we believe that we need to come up with problems that are cross-disciplinary, bounded, so enough that can be developed in a one-semester type course across different disciplines. The second big idea is that these problems need to be interwoven into different disciplines of engineering and also different years, so from first to the fourth year of engineering. And we're going to talk a little bit about how we plan on implementing this. And our last big idea is that this problem-based learning of grand challenges can positively impact student retention and success. So we started by looking at the grand challenges to pick one example problem to illustrate our idea here. So we looked at examples like coming up with more innovative medicine, making solar power more economically feasible. We ended up picking providing access to clean water, because 1 out of 6 people around the world do not have access to clean water. And double that don't have access to basic sanitation. So this was the problem that we're addressing. We also picked this problem because it does span multiple engineering disciplines, and our team here represents 4 engineering disciplines. So chemical engineering, civil engineering, industrial engineering, and mechanical engineering. So we wanted to span our multiple skill set as well. So here's the example that we're thinking here. So looking at this matrix, we're thinking of picking this problem here to illustrate our example. So clean water. We would provide this project to students in multiple disciplines, multiple departments, and multiple years. And we would strategically pick, so every semester we could pick a problem, a grand challenge problem for students to work on. And we would strategically pick classes in which we could fit this problem into. So we're looking at, for example, for the clean water problem, in chemical engineering, it would be year 2 thermo class, year 3 separations class. In civil engineering, could be the intro to civil engineering class at year 1, hydraulics in year 3, and it could be a senior level project management class. And I'll get back to those project management classes in a bit. In industrial engineering, your year 2 operations research class, and in mechanical engineering fluid dynamics class, you need somebody to design your pumps. Lastly, we added here electrical engineering to develop our control system at year 4. And we have the project managers here that could come from multiple departments, or it could even be representative of a senior capstone class. And these are the people that are overseeing this collaborative work by all of these different disciplines. So that's our idea here. It could be within a project management class that already exists in departments, or a senior capstone class. So some of the outcomes and metrics that we envision here for this endeavor is the percent retention improvement of students that are in the PULSED program as opposed to non-PULSED students. The second is qualitative assessment of student understanding of their role as engineers. So that's one big thing that we discussed is students, by working in different disciplines across different engineering disciplines, students would better understand what their specific role is in a larger project. So it would establish an identity as an engineer working in that bigger problem. Percent time using different engineering skill set at work. So this would be trying to evaluate how the PULSED program could impact their early career once they join the workforce, what is the percentage of skill sets that they're actually using at work because of their experience going through this grand challenges problem in PULSED. The next to last, assessment of communication effectiveness across disciplines. This would be before and after going through the PULSED experience. Do they become more effective communicators, especially across engineering disciplines, talking to people outside of their majors? And here we could use the KC Professional Skills Assessment Metrics. This was developed by the NAE. And lastly, industrial evaluation of PULSED versus non-PULSED skill set. So our industry could evaluate the quality of the students that they're hiring, the PULSED students as opposed to non-PULSED students. And I did skip mentioning that a big part of PULSED is also industry mentorship. So one big idea that we talked about as well is interweaving these larger problems in multiple disciplines and multiple courses would be we would be connecting with industry mentors, and these could be through companies that would sponsor a problem. So for example, the clean water problem, we thought about, we listed several companies and NGOs that we thought could sponsor this idea. And the sponsorship would not just be in terms of finances, but also providing a team of mentors that could support the students in the multiple engineering disciplines that were working in that project. And they could be the support structure, and also providing the student that real world experience, which our students, we see our students valuing so much. And I would like to open up for questions. Yes.
So I kind of worry that you're just focusing just on engineering, because if they were in the business world, they would do much, they'd be interacting with people beyond engineering to say, people looking at, say, the cost, and people, like, I'd say, looking at policy and looking at all sorts of different factors, societal factors. So it kind of worries me that you're just talking, I'm not saying that's not a good goal, to have just to talk to, mechanicals, talk to civils and so forth, but I just don't think that's enough for a project class.
Yeah. We did talk about, so for example, in the project management aspect, the project managers could be students from the business school. So we were just trying to bound this problem right now to an example to discuss here, but definitely this could include different disciplines beyond engineering. The idea is cross-disciplinary, so it doesn't necessarily mean only engineering. The example that we gave was bounded, since we developed this in 30 minutes, that example. But that we did talk about even the project managers being business school students. Yes? Awesome. Can you wait for the mic?
Hi, it's an awesome idea. One question is, one obvious challenge here is, due to its expansiveness, there's lots of sort of people who need to buy in. So, the professor of your thermo class, the professor of your controls class. And so I wonder if you can, it's only been a half-hour project, so I don't want to put you on the spot, but have you thought about, strategies in which you could sort of convince, all the faculty would have to be involved to sort of develop curriculum and integrate this into their classes?
So the cool thing about thinking about a problem that's limited to one semester and one problem is you could literally, because even the clean water problem, you could pick and choose what are the engineering disciplines that could be involved in that project based on who you get buy-in from. Right? So it doesn't have to be a semester-long project. It can be one assignment that a piece of a class can contribute to that larger project. But at the beginning or right before the semester we could sit as a faculty, figure out who wants to participate that semester and bound the problem that way. So in our example, we had 5 different engineering disciplines. Could be more, include somebody from business school, could include somebody from the School of Architecture or other departments, but we could customize our bounds based on the buy-in that we get. Yeah.
We also mentioned the possibility of having like a tech elective. So it will be run by one professor, I guess. And then the specifications as far as knowledge for the students will be kind of, this is the minimum requirement that we will need. So for that project, anyone from Civil engineering second year will be able to participate on that project because they already have that knowledge. So it's building on the knowledge that they have gained. So it's not necessarily within the constraint of one course.
Son? Okay, so it's a great idea. It immediately brings to mind things like the IGERT program that is all about bringing together all these different multidisciplinary teams. I wonder if there are things that you could learn from that to apply to this, but also just simple issues like having the team being able to effectively communicate together. Sometimes that could take up to a full semester. So is this something that would potentially be a problem or a challenge, or how do you see that?
You want to address that one? Communication?
So clearly, yes, we could learn from what has been done with the IGET program. That's worth checking out. Now, in terms of communication, I'm going to speak from the background of colleagues who've actually run something similar over the summer. I had a colleague of mine, mechanical engineer. Another one was a physicist, and one from humanities, communication. They created a course to address the grand challenge, and it was kind of similar to what we had today on clean water. And this was a 10-week course. So to address the communication, yes, you need to make sure that at the beginning that's addressed, but it's got to be a continuous thing all the way through, because it's not just communication within the team, it's communication with other stakeholders, and then finally, how you're going to communicate your product, your final results out. So it's an ongoing problem.
And I'll just complement that response by going back to that example that I talked about, the collaboration in the two classes that were different classes between UT Austin and the University of Southern California. So what we did there, those were two different classes, just like we're thinking about here, right? So we bounded the problem very well, and we really control the interfaces between the students. So I think that's key to make this successful, is to really bound what is the contribution of each of the pieces of the puzzle, and when do they contribute? So when does the student from Intro to Civil Engineering send their input to students from the chemical engineering to the chemical engineering department, and so forth? So managing the interfaces is really the key point to really making this successful. And that's we were able to do that in one example setting between two universities, two different classes as well. But this would be much larger.
And I just wanted to add to that, because I think that we can tell students a lot about how to communicate, but until they actually need to do that and to take their knowledge and the inputs that they need from their colleagues and explain that and explain why, they don't really get it. So I think having those points where you can interject with strategies for communication are really key to teaching that skill.
So two of the points that you hit on in the beginning were kind of diversity and retention issues. So I'm wondering how you would attack the problem of scalability. So it seems like this may be a small cohort and really amenable to a small cohort, but how do you deal with issues of scalability to a larger student population?
I was told to say that was the question we had for you, but I mean, not to pick on Purdue or anything, but Purdue does this, right, in EPICS, right? It's quite scalable. It means you have to have very good mentors. It means that you have to have students who are willing to do it, but part of the hypothesis behind the research is the idea that this would bring in a more diverse set of students and hopefully help satisfy some of their needs we heard about earlier this morning, and it might be somewhat self-selective towards that goal. How do you scale in general? That's a huge challenge. As a few people have pointed out now, we went with what we thought was not too big or not too small, but there is the issue of could you go smaller or could you go bigger, and that's something we definitely have to work through, no doubt.